So glad to be here and so excited to be kicking off this conference. This is going to be a very, very interesting set of 4 hours. We're going to talk a lot about kind of GraphQL and GraphQL's role in enterprise. It's something that we don't talk about often enough. We talk a lot about kind of GraphQL in kind of modern and application development context, which is kind of restricted. And it seems, that a lot of the GraphQL action is very kind of restricted towards folks who are in with the latest web development trends, right? But GraphQL also has a significant kind of role that it can play in enterprise, specifically in activating data and empowering developers, right? And as soon as that happens, innovation kind of gets enabled and unlocked, right? And that's kind of the theme of this conference. And we're going to talk a lot about kind of the enterprise opportunities, challenges, and success stories related to kind of GraphQL and related to kind of activating data. So that's going to be, that's going to be what we're going to see in the next few talks, in the panel discussions, and in the topic tables during the next 4 hours. So with that said, let me kind of dive right in and set a little bit of context. I'm not going to introduce GraphQL too much. I'm hoping that you're familiar and you've heard the usual story. GraphQL was founded, and GraphQL was started at Facebook. It was open source in 2015. It was started as kind of this API layer to optimize communication between the Facebook backend and their front-end application. Started off with their iOS app, in fact, and so on and so forth. And you should definitely go and watch those kind of talks about how GraphQL started. It'll give you a tremendous amount of context in kind of how GraphQL has come to be, and it'll give you insight into the specification as well. And they talks from about a few years ago by the Facebook folks when they announced GraphQL. So definitely worth a watch. But with that said, let me start off by kind of introducing the data access kind of concept and the challenges there. So let me hit next here. All right. So when we think about kind of, what is happening with developers today, right? And in the kind of overall landscape, on the right, you see, kind of what developers are doing today, right? Let me just quickly enable my little pointer here. All right. So on the right, you see kind of how developers are, what developers are doing today, right? So the developers are consuming data to build mobile applications, web applications, increasingly writing serverless functions, or developers are, even outside the organization, right? It's a partner kind of, in a partner organization, they're using that data build stuff, right? And what is interesting about what's happening in this ecosystem, right, is that writing business logic and the associated operations of that business logic and deploying that is becoming easier and easier and easier. Sometimes you might get frustrated that there's a new framework every day for developers, but I mean, that's a good thing. That means that, it's maturing and people have a great amount of choice to say, if I want to build this kind of a thing, I have the perfect framework and the perfect language for doing that. If I want to build this kind of a thing, I have that. I can deploy it wherever I want. And that's a sign of that ecosystem maturing, right? And on the left here, we have kind of where data is, right? And that is a combination of where data is and where data is increasingly going to be, right? So you have data inside databases, and databases have become better and better over time, right? Over the last 20 years itself, you've seen this rapid kind of advancement of, moving from SQL databases to key values databases to document databases, to coming back to kind of new SQL databases, which are SQL databases, but ready for kind of scaling out, right? And there's a tremendous amount of work that's happening there. But data is also getting split across multiple sources. So we're seeing data in, it might be data that is kind of owned by a different team, not the team that you are working with, and not the team that is kind of building a particular application, but that data might be coming in from another team or another domain. Or that data might be coming in from a SaaS service like Salesforce or Stripe, right? So that source of truth is kind of getting fragmented across data sources, and it's only increasing. If you're familiar with the kind of Jamstack ecosystem, then and you look at a modern Jamstack site that somebody's put together, and you ask them, where is the source of truth of this application? You'll be like, well, my authentication stuff is inside an auth provider. That's where my user's source of truth is, and then I have some transactional data maybe in Postgres, and then I have content data inside a CMS, which is on a SaaS service, right? And so it's kind of all over the place, right? And that is also a nice thing because more problems are getting solved for us and it's more managed. And James is going to talk a little bit about that in the next session. But what emerges is that in the middle, what you need for this to happen is that you need data access, and you need to build that data access service to kind of bridge this to the folks here, right? And this piece takes a fair bit of time to build, and iterate on, right? That's kind of the story in which GraphQL starts seeing a tremendous amount of success. Or let's say GraphQL gives us an opportunity to kind of tackle this problem in a slightly different way. So before we kind of get to that, let's take a look at when we think about data access and why it's challenging. Why is it challenging, right? There are three elements to this, and that I'll talk about. I'll talk about where is your data, what is accessing your data, and who is accessing your data. And these are kind of the three problems that we have to think about when we think about data access, right? So the first is when you think about where your data is, like I said, your data is increasingly getting split across sources. And people often call this polyglot data. So you have a transaction database, you have a search optimized database, you have services that are, if you think of SaaS services also kind of like databases with stored procedures, right? That's kind of essentially what a SaaS service is. But data is in kind of these multiple places, right? And that's only increasing. That split between data being in multiple data sources is only increasing because niche databases are getting better and better at what they do, right? The challenge here is that you need this layer here that enforces a common semantic model across these data sources, and you might want to enforce a central kind of authorization and central governance when you're kind of getting data from these data models, right? That's the context in which we're kind of getting this. As developers, when we get this data, right, what we want is we want a unified JSON experience, right? This is what we want, right? So when somebody's building APIs to do this, like a REST API or whatever, it often and most commonly returns data in JSON, especially if you're building new things today, right? And it's kind of one of the ways that I think about it. It's kind of like saying that if all of my data, wherever it was, came together as a gigantic Mongo, right? Like a gigantic Mongo database, like a giant MongoDB, where it's like a set of interconnected documents, right? That's the ideal experience because everything that we are doing as developers is JSON is well suited, right? I mean, on top of JSON is really nice to use as a human being as opposed to say XML. But on top of JSON, we also need well-defined contracts, and this, in a sense, has kind of been a bit of a little bit of a failing of JSON almost, right? It needs to be a little more well-defined than just JSON, which is entirely dynamically typed or quote unquote unstructured, right? So you need a slightly better contract, especially as things become more complicated. And then of course what you want is that you want all of this over a web or an HTTP API, ideally, right? So that you don't have to deal with different connection drivers connecting to different things and different ways of talking to different things, right? And also because it's a nice stateless protocol. So that's what we want, right? And the challenge here, the key challenge here is that if we set about building this, right, there is a tremendous amount of work required to provide APIs for every possible slice of data that developers want, right? So if the developer that's consuming this data wants a particular slice from this and this, that's a new endpoint that you have to make, right? Traditionally, that's what we had to do. We've had to make a new endpoint for each and everything, right? For each and every slice of data or shape of data that we want. And then the same work that has to be done here has to be done again. You have to bridge over these things, enforce authorization again, and set that up, right? And that's kind of been the challenge. And again, for those of you familiar with GraphQL, you can see why GraphQL addresses some of these problems in a better way, right? And so that's kind of one problem. And the other problem also, especially as enterprises are starting to modernize, is there's this gradual, people want it to be faster, but there is a gradual kind of transformation that's happening where data is online data. People want to move online data from older data services or older databases to newer databases, right? Maybe you want to move all of that data, right? For an existing application, you want to take all of that data that's there in the old database, move it to a new database. Maybe you're saying that, well, I don't want to move all the data. I'm going to let some of the transactions be here, but then I'm going to take this part of the data and move it into this new database here, right? And you want to do that so that you can kind of, accelerate development on this application. But this online data migration is a huge challenge, right? You can't suddenly shut down this database and say, well, you know what, we're going to close this and we're going to do a lift and shift migration. And we're going to do like a database dump, and then we're going to bring that database here, right? That is almost impossible because there's so many layers of things that depend on this old database. So you need that kind of online migration to happen gradually, right? And so as developers who are kind of consuming this, right, who are building this kind of little blue application here, we want an API that helps us kind of bridge between that old and the new easily. And we kind of want it to be compatible, right? We want to be compatible with what we had before, what we have. What the new thing is, it doesn't mean that the API is the same, but it does have to have a degree of backwards compatibility, so that this movement is a little bit decoupled from the movement that I am doing as an application developer to switch to a newer data source, right? And the challenge here is that the owners of the data here, right, the people who own this data and the people who are managing this database, they need to now maintain multiple simultaneous APIs across old and new data sources, right? And that's a challenge. If you think about what is accessing your data, right? We looked at like the where is your data. If you think about what is accessing your data, you'll see that another common pattern in enterprise is that you have a tremendous amount of existing online data, right? This is live data. This is an application that exists today that is serving tens of millions of customers, or that is serving business critical workloads, right? And you want to build new applications on it, right? So you want to say, well, I want to build a new capability that's going to access a part or a slice of this data. And these new applications might be on the cloud, but these existing applications, they might be on self-hosted data center, right? It might be a hybrid kind of architecture that you have in your cloud setup. And this is a little bit scary to do, right? And as developers, all we want to do is access parts of that we need to build our stuff, right? The challenge here, though, is that network and data security need to be thought about, right? And that means somebody needs to set something up here so that they can create that bridge for network and data security. And I mean, you need to create that bridge, because if you try to give direct access to this existing online database, that's not going to be allowed, because you're going to affect like existing non-function requirements on performance or security or scalability that this application has. So you are not going to get direct access to this database here and say, yeah, we'll access this directly and do whatever you want. That is not happening. And you need something to arbitrate that security boundary, especially if it's maybe over a different network, right? Maybe it's this is running on the cloud, this is not running on the cloud, right? You need something here. And again, you kind of almost want database access, but you want API-like control, right? So you want the control of as if we built an API, but you want flexible data access, right? That's kind of the challenge and what we need here and what we want here. The other part of what is accessing your data is that increasingly, cloud native applications are the things that are consuming data, right? And here the important context here is that these applications, they're being written on compute that is stateless and compute that can scale massively, right? So this thing can scale. This thing can scale and say, we'll have 100,000 concurrent executions, and the cloud vendors will give you 100,000 concurrent runs of the application that you have, right? Whether it's a bunch of containers that are scaling out, or whether it's the serverless functions or workloads on the edge, or even apps, which are essentially decoupled entirely. And there can be 100,000 concurrent users or apps that are connecting to and trying to fetch data. And this piece is kind of becoming easier to deploy. It's scaling automatically. It's scaling on demand, right? And what we want as developers who are building this is we don't really want to care about stateful connections to something, and we don't want to manage those stateful connections. We want a quote unquote web scale API, right? Web scale. Always when I use the word web scale, and this is why I always put it in quotes, reminds me of the very funny MongoDB video that came out, I think many years ago. But anyway, but we want a web API, right? We don't want a stateful API. We don't want to manage connection pooling. We don't want to figure out how to. Our app has now scaled to 5. That means the connection pool of 100 has to be split by 5, so everybody should get 20. We don't want to think about that kind of stuff. And the challenge is, of course, that databases prefer stateful interaction. Databases like interacting over TCP and having persistent connections, right? Which is not what you want to do. And again, you can see that you need kind of a layer here, right? The last piece of the challenge around accessing data is who is accessing your data. And these are almost organizational challenges, but also technical challenges, right? So let's say, for example, we're in team 2 and team 1 has some data and we really want that, right? This is kind of closely related to that previous use case that we talked about of, a new application on existing data. But let's say that data is with team 1 and we are team 2 and we want to build stuff with that data. And if I want to pull this online real-time data, one option is that, team one starts putting all of their data in a warehouse, and then we access data from that warehouse, which is fine. But then that data is not going to be online or real-time. That data is going to be loaded in by batches. It's maybe several hours old or several days old, right? So it's not fun. What we want as developers is to be able to access this data without bothering the team one folks, right? We want access to data and we don't want to bother team one. And I mean, the reason here is unfortunate, but this team does not really care about this team's roadmap and vice versa, right? So if I want a new API endpoint that gives me access to some more data, it's going to be hard to convince this team and say, team one, why don't you build this API endpoint for me? And team one is like, I don't have time, right? And it's not like people are evil. It's just that there's different contexts, right? And this is the reality of what the situation is. So the last piece here, the last challenge here is when we think again about who's accessing your data. Well, humans are accessing this data. And the context is that the amount of data that we have, and online data that we have, is increasing. It's becoming dynamic. There is a lot of it, and it's not stopping. It's not like becoming lesser or more sane. It's just exploding like crazy, right? And that means there's more APIs, there's more models, there's a lot of domain-specific context, there's a lot of data context. And this is, as developers, we dream the ideal onboarding for a developer on a team, right? You join a new team, you want to build something, you're building a new product. Your ideal experience is that on the very first day, you get productive and you build features and you ship something, or you're able to build a capability on almost the first day of your onboarding, right? That is the ideal onboarding. Except when you have this, it is hard. It is really, really hard to understand what's happening. And if you try to maintain all of this information asynchronously in a separate data catalog, that's a bigger challenge, right? It's almost like saying we should have good documentation. Well, of course we should have good documentation, but people don't document stuff. Documentation is always out of date. Documentation is asynchronous, right? So imagine that if documentation is hard, who's going to catalog all your data manually, right? And again, it's a little bit of an organizational problem because this data is coming from multiple places. So nobody's really incentivized to create a central place to catalog your data, right? Nobody wants to do that, right? Like, the organization wants to do that. It's a bit of a tragedy of the common situation. But the individual teams are not like, well, we will take responsibility of a central data catalog. It's hard, right? There are challenges here. In all of this, what I talked about here, if you look at the left side here, is that, as developers, in this context of whatever we saw and problems that we understood, we want a web API. We want it to be HTTP and JSON. That's what we like. We want a flexible way to access data because there is so much data. It's blocked on somebody else giving us access. We don't want to get blocked on humans. We want to get access. You want to get access kind of a flexible way, but with controls in place, right? So we don't want to get blocked on other human beings to use that data. And you want kind of better tooling to consume these APIs and deal with these APIs, right? So you want kind of an automated discovery and onboarding experience. Now, none of these things that I've talked about are new, right? These are age-old problems. These have problems been since like the very first time data came along and got saved and somebody wanted to do something with that data, right? But why are we talking about it now? And two, there are two big reasons behind why this is becoming a bigger deal, right? One, as an enterprise, being slow to innovate today is a huge business risk. Every day things become kind of more and more competitive for everybody, right? And so being slow to innovate is the cycles at which we are taking things to market has changed and has reduced drastically, right? When we think about why digital transformation is happening or why we're even doing cloud native or Kubernetes or anything, all of that is driven by this need to understand that if you are slow to innovate, there is a huge risk, right? Which means that things that will accelerate and enable developers are becoming super, super important. And this is a huge bottleneck. As developers, if you think about why this problem is new today, it's because that amount of data that is exploding is forever increasing, and it is posing a significant risk to our sanity as developers who have to use this, because you just like, what is even happening with the number of APIs and services and data models that we have, right? So in this context, GraphQL is nice. because when I talked about kind of those points, we have Web API. GraphQL is first-class JSON. It's over HTTP. I mean, it can be done over anything, but most commonly GraphQL is delivered over HTTP, which is nice. GraphQL is flexible, unlike a static REST endpoint. You get to query for what you want, right? So you get to say that I want only this part of the data, or I want like these parts of the data, or this slice, and it's kind of like a low-code experience of consuming APIs. You don't have to build a new API endpoint for what you want to do. It just exists because it's a query language more than a static endpoint. And the third is that you have, because GraphQL is typed, it presents a schema of the entire API that's available, and that schema can actually be introspected. So that means you can go fetch data about the GraphQL schema and say, tell me what the APIs are. And so that documentation and onboarding experience is not entirely automated, but becomes easier to automate because of the nature of the technology here. Again, this is not new, right? For all of you who've been in enterprise and who've worked with systems for longer than the last 5 years, you would have seen SOAP and OData, which aim to solve similar problems. However, they suffered from a fundamental technical problem, which is that they were a little bit yuck. It's a joke there. I mean, it's not a technical problem, but it is a human problem. And GraphQL is a nicer API to consume, right? SOAP is also super flexible, but it's over XML. It's actually hyper flexible and has a lot more kind of definition than GraphQL does, right? OData is over JSON and REST, but it's not a really nice API to browse and use, right? And both of them have introspectable elements, but because they're not very nice to use, the tooling did not develop at the same rate that it has for GraphQL, right? There are other differences as well, but really technically, it mostly boils down to the amazing experience that you have with GraphQL, right? Like I said, GraphQL is shamelessly JSON and, of course, more human-friendly. All right. So for those of you who have not seen GraphQL before, this is a quick screenshot from the Hasura console. This is kind of an HTTP endpoint at which you're making that GraphQL query. So you can see HTTP here. You can see that this is the GraphQL query. So this is posted as a payload to this endpoint, and that results in this JSON data. And in this query, if you remove certain fields, you'll only get that data. So if I say I want artist ID and name, you'll just get ID and name. You won't get this stuff, right? If you look at this tool here, Graphql, and then OneGraph, and then the Explorer here, right? When I hover over here, I got a little thing that said, oh, albums are title, that's a string, right? And an exclamation point is that it's not nullable. This tool here is not a custom, it's not a custom tool that you need to build yourself. Graphql is, you can point Graphql to any GraphQL API, and you will get this experience where it will tell you, hey, you know what? These are all of the things that you can query. And then you can like click on little buttons and say, I want ID and title. What else do I have? I can do a limit or an offset, or I can fetch the albums data and I can say I want the ID and title from the album, and I want the ID and name of the artist, right? And this UI, right, the kind of this documentation snippet that you see here, or this type snippet that you see here, and this Explorer sidebar that you see here, is auto-generated because the GraphQL endpoint is introspectable. So this tool, Graphql, makes a query to this endpoint, fetches the schema, and shows you this sidebar. And this sidebar then shows you what the different fields that are available in your API. What are these different endpoints? Not endpoints, but what are these different endpoints that you have that you can query, right? And so I'm just going to quickly skip through this. All right. So in the last few minutes that I have, as a former GraphQL skeptic that adopted GraphQL a little bit late in their life, I want to talk a little bit about GraphQL Challenges. GraphQL is amazing. It's an opportunity. All of the problems that I talked about before don't actually get solved with GraphQL. You have to solve them. GraphQL offers an opportunity and a vocabulary to try to address these problems, right? And a lot of the pros and cons of GraphQL come from the fact that you've kind of given away control to the API consumer, right? And so a lot of the ways of thinking about the world that we had with REST don't directly map to what you want to do, right? And so I'm going to quickly rush through a bunch of GraphQL challenges, and we'll get to talk a bunch of these challenges through the talks that we have today, and even in the topic tables, right? So I'm going to talk about challenges that developers face, which are some of these, and challenges that ops people face, which are some of these, and challenges that businesses face, which is that, oops, we do all of this work, we figure all of this out, and then what if GraphQL is not around tomorrow, right? What happens then? So these are serious and pretty real challenges. So let me quickly zoom through them in the next few minutes that I have. All right. So when you think about performance and data fetching with GraphQL, you're fetching whatever data that you want, right? Unlike a REST endpoint, where the provider of data knows what data has to be sent. So that data provider can do a lot of optimization to figure out, if this API endpoint is slow, they can figure out a lot of stuff to kind of make it fast. But with GraphQL, it's kind of happening dynamically, right? So how do you think about it, right? And that changes the way that you think. You could make a query to fetch each of these individually. And if you try to kind of procedurally loop through it, you will hit the database like exponentially increasing number of times, like n plus 1 into n, right? The number of nodes that you have. I won't get into details here, but also for the n plus 1 problem. You can use a data loader pattern, and then you can hit the database n times. But you could also do like a explosive Cartesian product and join everything and fetch it, which might result in too much data getting returned from the database because it's a Cartesian product. Or you can do a single query with JSON aggregations. Now, different, depending on the kind of database that you're working with, these things could have different performance considerations. And those are the kinds of things that you need to think about, right? When you think about subscriptions and WebSockets, GraphQL offers an opportunity to subscribe to real-time and changing data over a subscription specification, which is commonly implemented over WebSockets. But for any of you who've done WebSocket and concurrent programming, it's interesting, right? It's interesting to get all of those pieces working together, you think you've solved a problem, but then that kind of opens up another can of worms, right? When we think about authorization with GraphQL, in fact, this is one of those big challenges for enterprise, which is that the auth landscape is quite complex and it's very customized, right? When you think about optimizing performance of authorization, there's like predicate pushdowns that we need to do. I'm not going to get into details. A very exciting idea here is role-based schemas, right? For example, if you had a API registry, you could say that certain roles have access to certain API endpoints, right? But with GraphQL, everybody gets the full schema. So it's exciting to explore this kind of idea of saying, well, can we mask the schema for certain roles, right? And what would that look like? And a lot of these challenges that I'm talking about a lot of them are open challenges, and there's different kind of solutions that people are trying out to do it, but to solve these problems. But this is kind of the space of challenges, right? I'm going to skip over these bits because this is going to be available, and I'm going to publish this and take you over to the end of things. But very similar to authorization, you also have transactions because now you're talking to multiple data sources. So, mutations. So mutations are going to be interesting because, how are you, a GraphQL mutation block specifies that you can run multiple mutations, but is that all or nothing? Is that one by one? If it's one by one, what happens if there's an error? You need to think about these right semantics when you're exposing mutations. Whether you expose it at the API level or the data level, this problem is something that you want to make sure everybody understands and is on the same page about, right? Caching, which the whole set of things to talk about, which I'm going to skip. This is the Explorer sidebar that I showed you. Props to the folks at OneGraph who set up this Explorer. But we need more tooling, a lot more tooling, which is kind of not just like styling GraphQL and making it look nice, but also fundamental tooling that tells us a little more and gives us more information about what this data is coming from, how it's being used, encourage people to kind of make good queries upfront or analyze the cost of their queries and think about that, right? And of course, folks like OneGraph pushing the open source ecosystem forward with this, amazing tool, right? It's a simple thing, but it makes life super productive. And so there's a bunch of things that need to happen here as well. For operational folks, nothing is easy. You have GraphQL, which seems like you solved everything, but suddenly you have a single point of failure. And this is kind of like the traditional gateway challenge, right? You have to figure out, how you're going to do rollouts of this thing without causing a downtime. You have to understand the failover mechanisms or the circuit breaking mechanisms of whatever you're talking to upstream. How do you ensure that when you're scaling this out, you don't end up destroying an upstream data source, right? Or if the upstream data source has to give you indications saying that, hey, 4 to 9, status code 4 to 9, with too many requests happening right now. How do you handle that, right? And those kinds of challenges that start to show up operationally. Operationally, when you think about monitoring and performance and health, that also changes with GraphQL. For example, you might want to integrate with distributed tracing specifications to trace all of the things that are happening across your services, right? And so you need a spec and a way of integrating that, pushing that out. Now, this is hard because distributed tracing itself has become better, but has not matured so much that there is like the one spec that we will use, right? There's a bunch of different specifications and they kind of loosely say the same thing, but that integration is required and is missing. One of the big challenges with GraphQL, especially if you think about the enterprise API landscape, is that you don't have status codes anymore. And we really relied a lot on status codes, right? Because when you get a status code, you don't need to peek inside the response body. You can just look at the status code and say, hey, this is successful, this is an error, and so send out an alert. But now you have to peek inside the response body and parse the response body to see whether there's an error inside, right? Because we have only one endpoint, and we're sending a query to that, and we're getting data and errors as a response body, right? And so that mapping needs to be created, and there is a challenge here, right? As you use GraphQL, you realize that you kind of start needing deeper and deeper instrumentation inside your code base, right? Where a lot of the vendor tooling that you relied on to kind of make the operational aspect of APIs easier, those start to disappear, right? And you need to think about that carefully and the cost of that. For example, when you think about things like rate limiting or denial of service protection, right? You have to think about, is this a public API? Is this a private API? Are we going to have a flexible API in development, but a fixed API in production, right? Which is also called, like, for example, things like persistent queries. Are we going to have a rate limiting based on static rules, or is it going to be cost based? How are we going to measure cost? What does that mean? New things, new opportunities, new challenges, right? All right. So hopefully I've been enough of a motivator and a downer over the various challenges that we have in front of us when we think about GraphQL in the enterprise space. And over the next few talks, we're going to see opportunities and success stories and approaches that people have taken. James is going to talk about industry trends where we're seeing more and more kind of services moving inside a managed service kind of landscape and the kind of opportunities that we have with GraphQL there. Adam from Airbnb is going to talk about the tremendously interesting work that they're doing at Airbnb, and kind of this aspect of moving from being service-oriented as an organization to being data-oriented in an organization, which is extremely interesting. In fact, if it depending on how these things evolve, we could be in the middle of this massive paradigm shift. And the folks from United Health at Optum are going to talk a little bit about the healthcare context, which has been tremendously stressed over the last year, and their requirement for massively accelerated innovation in enterprise, and how GraphQL has enabled slices of that. We're going to have two panel discussions. We're going to do a data federation panel discussion with Diana, Deep, Bhaskar, and me. And we're going to talk about data federation with or without GraphQL, what federation means, what the opportunities of federation are, how we can, what it means to when do you know that you need data federation? When do you know that, no, this is not data federation, right? And the prior work that has been happening in the industry and what we can learn from that when we think about federation. And lastly, we'll also be having a panel on kind of moving fast, enabling developers with GraphQL and seeing success stories there at scale with Evan from Shopify and Ashwin from Swiggy. Swiggy, if you folks are not familiar, is one of the largest food delivery applications in India, with the tens of millions, I think nearing 100 million users, and understanding kind of how they think about using GraphQL and how they've rolled out GraphQL and what impact it's had on their developers, right? So that's going to be the set of talks today, and I'm hoping that we learn. There's a tremendous amount of sharing, conversations that happen. Please do feel free to reach out to me if you have any questions. I'm always available on Twitter and on LinkedIn. And now I shall pause and take a breath for any questions.
So yeah, I definitely encourage taking a breath after that. That was amazing. Thank you, Tanmai. I greatly appreciate it. Do want to encourage those who are watching to please feel free to put in questions you may have. We'll address them live as we can. And as Tanmai said, we'll follow up on the things we can't. The question came up multiple times. Yes, this is recorded and the presentation will be made available as we can. Tanmai, you addressed quite a few challenges that face us as an industry, not just sort of Hasura as an organization, but us as an industry as we think about GraphQL and adoption and its maturation. I guess as you think through those, how would you recommend people incorporate or perhaps move to GraphQL in an incremental fashion rather than sort of whole hog?
That's a very good question. I mean, that's in fact in many places it's quite literally the $1 million question, right? And there are many different ways to kind of approach this, right? One is to kind of really look at places where GraphQL is going to require a significant shift. It's going to be new. It's going to be new from a technology point of view, from a process point of view, right? So what you want to do is identify a place where that impact of GraphQL is going to be as massive and as positive as possible, right? So that the cost of switching over to GraphQL is justified, and you make sure that you don't take on more pain and more work than you do. And when you think about kind of adopting GraphQL, there are multiple strategies, right? So one approach that people have taken is that you have you add a GraphQL layer in front of your REST APIs. And that is kind of an approach that is kind of at the edge where you're not really changing anything, but you're adding a GraphQL layer. This has its pros and cons. There's slightly new operational challenges that are introduced, but you're not affecting the rest of the stack too much. The approach that we've seen be tremendously successful with Hasura is that we kind of activate that data directly where it is, alongside the existing kind of application. So if it's a new application, that's totally fine. But if it's an existing application, you have that application running, you use a layer like Hasura that is kind of giving you that GraphQL interface to your data. You set up your security rules and you connect it to your data systems and whatever, the right way that you can. And then you gradually, if you have this existing application, migrate your reads to GraphQL first. So moving your reads to GraphQL first instead of your entire API or your entire application has a tremendous impact, especially because most applications are read heavy anyway. And that is a good first step. The next step is when you're kind of bringing in mutations, you're either mapping those mutations to REST APIs and then bringing it back to the graph or whatever kind of approach works for you. Or if you're moving to an event-driven pattern, then you're kind of mapping those mutations to events that are then going and doing something else and triggering a workflow perhaps, right? Whatever that mutation or business logic workflow is. But that is another approach to kind of migrating to GraphQL. Another thing that we've been thinking about that and there's been some interesting prior work done in the community by I think the Guild folks is to kind of offset that risk of GraphQL adoption by providing by interop with REST, right? So you can have a GraphQL layer, but then you can also have a REST layer, a REST API that works almost alongside GraphQL, or you can think of it as having GraphQL queries which are super flexible, but parameterizing them and creating a REST endpoint out of that, right? So that now for the consumers, you effectively have the same backend, but you can switch between REST and GraphQL too, right? And those are kind of the different ways to mitigate the risk. I would say that the two things that are really important is that one, the data that you have and the way that you have that data, that is critical to the organization, right? That needs to be the way you want it to be. When you think about business logic and how developers are writing business logic, that needs to be the way developers are comfortable writing business logic. If you change that too much, you risk making the developers learn more about technology rather than learning about their domain and solving domain-specific problems, right? So you want to let developers continue doing that, right? As your organization grows, it is ideal to start having a platform team or a technology that helps you set up that GraphQL layer and that helps you maintain that GraphQL layer as much as possible. And so that there's a team that can take care of the GraphQL specific problems so that everybody else can focus on their data problems and their business logic problems, not the GraphQL problems, right? And that is important in the slightly longer term. Long-winded answer, but I hope that made a little bit of sense.
No, it made a lot of sense. And the notion of moving from sort of initial design and exploration and understanding to what some would call sort of a center of excellence around an approach, I think is one that resonates with me. We just have a few more minutes, so I'm going to ask you one sort of last short question, which is, it was new to me. You mentioned you were a former GraphQL skeptic. What changed?
This is true. Yeah. So we built our own version of GraphQL at the time, which was as if GraphQL was in JSON. So you would have a JSON query, kind of like OData, kind of like somewhere between OData and GraphQL, right? Is what we built. What we did not realize was how powerful the ergonomics of an API can be that result in the network effects of creating community tooling, right? As that started to happen, the GraphQL is a new language. It's a new specification. You can't natively write GraphQL in your applications. You have to write a string, like you have to write a GraphQL string. There's no native representation for GraphQL, like the way you have a native representation for JSON. A JavaScript object is almost a native representation for JSON. You don't have that for GraphQL. There's a lot of new complexity that GraphQL brings in. But that complexity started getting offset when the community started building tooling, like I showed you, like the Explorer, like Graphql, clients, right? Ways to automatically explore documentation. Those are the kinds of things that suddenly made GraphQL tractable and actually possible for adoption. And as that started to shift, for me, I realized that there is a point where this complexity is now worth it. And you're now saying, if we're able to solve developer problems and make them move faster, and the community, and we can keep contributing to the community, and there's a flywheel that sets in of community tooling, then GraphQL becomes tractable, right? Because there's this huge cost of something that is new, which then starts becoming feasible when there's GraphQL. So that's kind of when my mind changed.
Yeah, that totally makes sense. Tanmai, thank you for this presentation. I appreciate the transparency, the perspective from someone who's building a company around this technology of what we as an industry still have to work on. For those watching either live presently or on a recording in the future, Tanmai made an offer, which is, as you have questions, reach out. It's at Tanmai Go on Twitter. So again, Tanmai, thank you so much for your time today.
Thanks, everybody. Great to be here, and hope you have fun at the conference.